In this next problem, we have a 2 kilogram object and it's initially at rest and then it's accelerated vertically by a rope as shown in the diagram below. And then the object reaches a height of 3 meters in 1.5 seconds. And our goal is to find the tension in the rope during this acceleration. Okay, so for this particular problem, there's two parts. Let's label this as part A, indicating the first part. And if I draw the free body diagram on the object here, once it's been raised by 3 meters, here's the force of gravity acting downwards. And then the rope also has a free body diagram, so we'll label that T for tension in the rope. Okay, so at situation A, I can create a F net equation there. So F net equals to, well, since the object is going in the upwards direction, the force and the tension is greater than the force of gravity, so tension minus F of G. Now, by using Newton's second law, I can write MA, so F net equals to MA, equals to the tension minus, and the force of gravity here is going to be M times G. Okay, and our goal is to find the tension, right? The tension in the rope. Now, we do know the mass. Mass is just going to be 2 kilograms. We know G is going to be 9.80. And then our goal now is to find the acceleration here. Now, in order to find the acceleration, we need to look at the problem at situation B when the object is on the ground and when it's being moved in the upwards direction and once it clears the 3 meters in 1.5 seconds. Okay, so when we're at situation B, the question literally tells us that it's initially at rest. So if we're initially at rest, we know the initial speed is going to be 0. And we know that it's reached a height of 3 meters. So the distance here is going to be 3 meters. And that's also done in about 1.5 seconds. So the time here is going to be 1.5 seconds. That's in meters. And our goal right now is that we want to find the acceleration given all this information, the initial speed, the distance, and the time. We need to find the acceleration here. Okay, so the kinematic equation that will help us for this particular problem is distance equals to initial speed times the time plus 1/2 AT squared. Okay, we know the initial speed is going to be 0, so this just cancels off, and we're given that the distance is equal to 1/2 AT squared. Okay, let's go ahead and plug in the numbers in now. So the distance is going to be 3 meters equals to 1/2 the acceleration, and the time is going to be 1.5 all to the power 2. And our goal here is to solve for acceleration here. If I want to get rid of this 2 here, I can just multiply the 3 by the 2. So 3 times 2 is going to be 6 equals to A times 1.5 squared. And then we can divide both sides of the equation by 1.5 all to the power 2. All right, so that just cancels off and that just cancels off. Okay, so now we can go to our calculator here, and if we go to our calculator here and just round this to roughly 3 decimal places, I get 2.667 meters per second squared. All right, so this number is going to be very important, and what we're going to do with this number now is we're going to go back to situation A now and go ahead and solve for that F net equation there. Okay, so let's go back to this part of the equation here. So we know the mass is going to be 2 kilograms, right? So going back to our F net equation, the mass is going to be 2 kilograms. The acceleration we already found is to be 2.667, so we can plug that in now. So 2.667 equals to the tension in the rope minus the mass, and the mass was 2 kilograms. And the acceleration due to gravity is 9.80. Okay. So I was going to erase a little bit of this, so we can create a little bit of space here. All right, so now we need to solve for this particular equation here. If I multiply 2 times 2.667, we get 5.333 repeating equals to the tension minus 2 times 9.80, which is negative 19.6. And then the tension in the rope is simply going to be the 5.333 repeating, and then we're going to add the 19.6, and then we finally get the tension as 24.93 to 2 units newtons there. Okay, so there's your tension in the rope there. So a very good multi-step problem for this particular question. in question number 9 here, I have a 4 kilogram block, and it's being accelerated along a level surface at 3.00 meters per second squared, and the applied force is 20 newtons. And we need to find the coefficient of friction between the block and the surface here. Okay, so for this particular problem, we can start off by labeling a free body diagram here. So if I draw a free body diagram, here's my force of gravity, and there's my force normal. And the question also tells us that we have a force applied here, force applied, 20 newtons there. And since we're looking for the coefficient of friction, we also have a force of friction acting in the left direction there. Okay, so there's my free body diagram, and based on my free body diagram, I will go ahead and create a F net equation here. So F net equals to, now since this problem is heading to the right direction, I know that the force applied will come first, so force applied, and then we subtract the force of friction. Okay, and then we can go ahead and use Newton's second law here, so mass times the acceleration equals to the force applied minus, well, force of friction is the coefficient of friction times the force normal, and we know that the force normal, which I'm highlighting in green, is equal to Fg, so I can erase the Fn and just write Fg. And we know Fg is just equal to the mass times the acceleration due to gravity. So instead of writing Fg, I can write m times g. Okay, so there you go. There's my equation there. And now we need to go to the problem and just grab all the numbers that we need here. So let me kind of go back to the problem. So I know the mass is 4 kilograms. So if I go down here, the mass is going to be 4. The acceleration here is going to be at 3.00. So my acceleration here is going to be 3. So 4 times 3 equals to the force applied. Well, the force applied is going to be 20 newtons. So that's going to be 20 minus, now our goal is to find this variable right there, right? The coefficient of friction, right? So that's the variable u. So I can write that as just the u there times the mass, which is 4, and the acceleration due to gravity is 9.80. Okay, so we have a very simple problem to solve here. Let's just go ahead and do the math here. So 4 times 3, that's going to be 12, equals to 20 minus the mu, and then 4 times, and then if we do 4 times 9.80, we get a value of 39.2. Okay, and if we go ahead and solve for this now, basically if I can bring this negative term to the other side here, it'll be u times 39.2 equals to 20 plus 12. Okay, and sorry, not 20 plus 12, it should be 20 minus 12. So 20 minus 12 is going to be 8, and then we have the u here, so 39.2, and then we can simply just divide both sides of the equation by 39.2. And if I divide that by 39.2, we should get a value of 0.204. So there is your coefficient of friction, and there's no units for that. Let's take a look at this next problem. We have a frictionless pulley, and it's set up with 2 hanging masses, as shown in the diagram below. And we want to find the tension in the right-hand rope while the masses move freely. Okay, so if the masses are moving freely, what we have to do is we have to find the heavier mass, which is the 5.1 kilograms. So the system is actually moving like this, towards the left. Okay, so since the 5.1 kilograms is heavier, as I mentioned, everything is moving towards the left here. So kind of like from here to here, right? So kind of like a counterclockwise direction. So that's very important to know before you start drawing your free body diagram. Okay, so if I want to draw my free body diagram, I have a red FG here, and there's also a tension in the rope. All right, so that's the free body diagram for the 5.1 kilogram mass. Now for the 2.4 kilogram mass, there's a tension in the rope, and there's also a force of gravity going in the downwards direction. Okay, so now that I've drawn a free body diagram, let's go ahead and create a F net equation here. So F net equals to, now since this pulley system is going in the counterclockwise direction, we have to work with the 5.1 kilogram mass first, right? So the whole system is going like this, right? So basically the red FG will come first. minus the tension in the rope. All right, and that allows the system to go towards the left-hand side, right, in the counterclockwise direction. All right, and then I need to add this to the free body diagram for the 2.4 kilogram mass. Well, we have to understand that the 2.4 kilogram mass is going in the upwards direction, right? So therefore, the tension comes first, and then we subtract the Fg. Right, so there's your F net equation right there. Now, if I go ahead and apply Newton's second law, F net is really mass times the acceleration, but it's really the total mass times the acceleration equals 2. Then I have my Fg minus your tension, and then you have your plus your tension, and then minus your Fg. And it turns out that the tension in the ropes, this negative T and this positive T, the red color and the blue colors, they just cancel out. All right, so now you just have Fg red minus Fg blue. All right, so let's go ahead and figure out what this will be. So this will be, I'll call this mass 1 times the acceleration due to gravity minus mass 2 times the acceleration due to gravity, and then we have our mass total over here times the acceleration. Okay, so let's go ahead and plug in the numbers, and what we're trying to do here first is we want to find the acceleration, and the acceleration will allow us to go ahead and go back to the free body diagram, and then we can calculate the tension in the right hand rope. Okay, so let's look at the mass total here. The total mass, well, we have the 5.1 kilograms and the 2.4, right? So we just add that together, so 5.1 plus the 2.4, and then we times that by the acceleration, equals to, well, mass 1 here is coming from the 5.1 kilograms here, so that's going to be 5.1 kilograms times the 9.80 minus the second mass, which is the smaller mass, and the smaller mass was 2.4 kilograms, right? So this will be 2.4 kilograms, and we times that by 9.80. Okay, so we're going to do the math here, and we're going to see if we can solve for the acceleration for this particular system. So if I go ahead and add the 5.1 and the 2.4, I get 7.5 times the acceleration equals 2. And if I go ahead and just multiply all this out here, if I go to a calculator and just put this whole expression into a calculator and hit the enter button, I get roughly 26.46. And then the acceleration, I can simply just divide the 26.46 and divide that by 7.5. And the acceleration for this particular system is going to be 3.528 meters per second squared. All right, and I'm going to use this particular number to go back now to find the tension in the rope here. Okay, so let's go back now, and let's go ahead and just erase some of the information that we have over here. And we want to find the tension in the right-hand rope. Okay, so here's the right-hand rope. Okay, so as mentioned, that the free body diagram, there's a tension there, and there's also a force of gravity going downwards there. If I had to create an F net equation for this particular block right here, I would label this F net equals to the blue tension minus the force of gravity. Okay, and then using Newton's second law, I have mass times acceleration equals to the tension in the rope minus m times g. Okay, now let's go ahead and plug in the numbers here. The mass for the block on the right hand side is going to be 2.4. And the acceleration for this whole system is the number that we just calculated, which is 3.528. And that's going to equal to the tension in the rope minus the mass, which is 2.4 for that particular block on the right-hand side, and then multiply that by 9.80. All right, so we have to do quite a bit of work for this particular question because we had to find the acceleration for the system, and then we go back and solve the individual F net equations for the block on the right hand side. Okay, so let's go ahead and just multiply this out. If I multiply these two numbers together, 2.4 times 3.528, I get roughly 8.4672, and that's going to equal to the tension minus, if I multiply that out, I get 23.52, and then if we add the 23.52 to the other side, roughly we get 31.987 newtons. Okay, and that is the solution for that particular problem.